Hello everyone, this is Oshan Shajid, and today we are going to see distributed mutual algorithm by Raymond. So yeah, this is the tree-based algorithm for distributed mutual exclusion. A unit token is shared among all the sites. Token means a special message which represents the right to access the critical section. A site is allowed to enter critical section if it possesses a token. Types of tokens based on algorithm: the broadcast token, and other one is a non-broadcast. Site does not broadcast, it sends a request along the directed edge to its folder. Site can send request along the directed edges only once. Every site maintains the request array of processes requesting the CS. uh, Arrangement of nodes. Let's see how the nodes are arranged. So nodes as are being arranged in an unrooted tree structure. It means that there is no fixed direction or no fixed particular direction in which the nodes are connected to each other. They are absolutely unrooted. So this figure shows the spanning tree of 6 nodes. See, consider the A B C D E F as an individual node. So when the system is initialized, one node is given the token, and that is a token means it's the just the privilege to enter the critical section. So let's see the structure. So yeah, the structure is like a tree with logical directed edges, all pointing in direction towards. That is node E. It is the privileged node right now. The edges of this tree are directional. They always point in one direction of the token. So that's the directional figure. Let's see this figure. So the following are the node variables. Consider these are the four variables of each node. So consider the node A. So it has 4 variables like holder to hold the value of the neighbor, or you can say of itself. And the other variable is its using. It is boolean type of variable. There are like its true, its values are like true or false. Third variable is request queue. So this is majorly used for requesting queue and all. So it shows its values of itself or its neighbor identity. And fourth variable and final most is ask. It's boolean type of variable which shows the values true or false. So yeah, so communication of algorithm, how these algorithm communicate with each other. So this the for the implementation, each node X should hold certain information. That it means that there are certain type of communication, like sending of request message and receiving of request message. So for sending of request message, you need to first make the request. If the holder and the self request, you need to check both the request queue and the holder. If they are true, then it will send a request to the holder, and it will then convert ask to true. So yeah, sending of the privileged message. How privileged message is sent? So the requirement for sending privileged message is its holder value should be true. So how to assign this privilege? If its holder is assigned to itself, then the current node got the privilege to enter the critical section. That's all it has. So yeah, there are certain events. See, when a node wishes to execute a critical section, it should have the privilege to use the critical section. So yeah, when the node receives a request message from one of its immediate neighbors, it means that it's enqueue the request. And when a node exists, so these are basically the events and the algorithm functionalities which are used for in this algorithm. So yeah, the using and make request, all these are the variables. So let's see the example of the algorithm, how there are the initial state and then final stages works, and how the nodes each other they make requests. So consider the first initial state. So node 2 needs the privilege to access the critical section. So node 2 will make request. So request by node aid, Then after getting the request from node 2, node A, it also wants to access the critical section. So yeah, in this figure node 6 is passing the token to node 3, and then it's eventually passing the token to node 2. And in this way you can see that how the token is passed to each node, and individual nodes are fulfilling their need to access the critical section. In execution of Raymond's algorithm is that its requests are not necessarily satisfied in same order which they were made. So in this example, see, the requests are made of the following order 8 to 6, but the granted in order are 8 6 2. So it completely depends how dense the tree is. So yeah, as let's see the correctness of this algorithm. So first condition is for mutual exclusion, at most one process can remain in critical section at any time. So and second one is the deadlock condition, like freedom from deadlock. So in every configuration at least one process must be eligible to take an action and enter into the critical section. So third one for correctness is starvation. So every process trying to enter in its critical section must eventually be succeed. So everyone should be access to critical section. So let's compare with some other algorithm like Makawa. So yeah, our algorithm like Makawa uses the surrogate mechanism, in which a node X requests another node Y to act on X behalf. Therefore node Y may act correctively, reduction the number of message requests required to affect the mutual exclusion. Its time complexity will be O log n, which is very good. So yeah, these are some reference which I used for this presentation. Thank you.